Hello, this is Algebra 2. We're in Chapter 7. This is Section 5, Page 1 of the notes. Here we have a bunch of properties of logarithms. Actually, I said a bunch, but really it's 3 of them, and we are going to use them over and over and over today. So, the first one is this product property, which says that if you have log base b of mn, now the key thing is that m is multiplied by n, then that's the same as log base b of m plus log base b of n. To be honest, I have no idea why they left those particular things blank. But this is an absolutely key property. I would circle it and star it. Unfortunately, the other two are also absolutely key, so it would just look cluttered if I did all that. So then you have the quotient property. Log base b of m divided by n is log base b of m minus log base b of n. So you're subtracting the logs. And then finally, the power property, and this is perhaps the strangest, but also definitely the coolest. It's log base b of m to the n, and that's n times log base b of m. So these are the 3 properties. They are super duper important. The first one says if you're multiplying inside a log, that's the same as adding the things separately, the logarithms separately, keeping that same base. The second property, the quotient property, says if you're dividing the things inside the logarithm, that's the same as 2 logarithms that are subtracted. And then the third one says if you have a power inside a logarithm, you can bring that power down for free. I get so excited by this one. You can bring that power down for free in front of the logarithm. Boom. 3 big properties. They all relate to the exponent properties from before. Normally when I try to explain that to students, they don't really believe me, so I'm not gonna stretch my credibility with you, but it's absolutely true. There we go. And then we can move onto example 1. Different properties, different examples of using these properties. So let's do part A. It says log base 5 of 4/9. Well, that's log base 5 of 4 minus log base 5 of 9. If you're dividing in the logarithm, that's the same as 2 separate logarithms that are subtracted. Log base 5 of 4 is about 0.861, and know that because it says that a little bit higher. And then we're subtracting, and then log base 5 of 9 is approximately 1.365, and so then in fact that is negative 0.504. This, by the way, is how division and multiplication, not logarithm stuff, but division and multiplication used to be done back in the ancient days before calculators. I think there were castles and dragons back then. I'm not really sure, but it's absolutely true that complicated arithmetic was done with logarithms back then. Let's look at part B. Log base 5 of 36. Well, they're reminding you that 36 is the same as 4 times 9. That is important here because now it's multiplication inside the logarithm. You can take that and make that 2 separate logarithms that are added together using that first property, the product property. And then we know that log base 5 of 4 is about 0.861. And we know that log base 5 of 9 is about 1.365. We know this, of course, only because it's written at the top of the example. We have no reason for knowing it otherwise. And then when you add them together, you get 2.226. Boom, boom, boom. And then finally, log base 5 of 81. Well, the key here is to notice that 81 is the same as 9 squared. Now you might want to stop me there and say, hey, now hold on there, buddy, because 9 squared is true, that's 81, but 81 is also 3 to the fourth. And if you said that to me, I would say, well, first of all, I'm not your buddy, but then also, it's true. 81 is 3 to the fourth, but the problem doesn't give us information about 3. It gives us information about 9. So we want to use the information we're given. So that's just why you would choose to write it as 9 squared. Now, this is the cool thing. This is the one I get super excited about. That 2 comes down in front, so it's 2 times log base 5 of 9. I didn't really write the times. It means times even if you don't write it. Boom. So it's about 2. It's a crummy 2. 2 times, and log base 5 of 9 is about 1.365. Boom. Multiply those together, and you end up with about 2.73. And that is example 1. All right. Now, let's go ahead and move on. You got this checkpoint. Now, they give you this information at the top. Log base 3 of 2 is 0.6309-ish, and log base 3 of 8 is 1.8928-ish, and you're meant to calculate these other values. Now, give yourself a shot here, right? Go ahead and try these on your own before you watch me solve them. So I'll wait a few seconds so you can pause this, try it yourself, and then resume after you've tried it. Okay, here's the first one. Log base 3 of 4. The first trick is taking that 4 and rewriting it as 2 squared, because, I love this, you take that 2, not the bottom 2, the top 2, that exponent 2, and that can come down in front, and that creates the 2 in front, and just log base 3 of 2. And then because of above, we know that is 0.6309, and then 2 is multiplied by that, and you end up with about 1.2619. If you haven't, take a moment to try to give yourself a chance to do number 2 on your own. This one actually can be done 2 ways using the information in the problem. I will do it both of the ways. So give it a try. Okay, so I wrote it out both ways. You've got what I called 2A and 2B. I did 2A first. What I mean is the first way I did it was I took that 16 and I rewrote that as 2 to the fourth, so I could bring the 4 down in front of the logarithm. And I just love that rule so much. I can't step away from it whenever it's a possibility. So it's 4 times that 0.6309. It's about 2.5236-ish. Yeah, give or take. But yeah, and then 2B, and this is actually the way the book wanted you to do it, but it doesn't really matter. They're both good ways. It's log base 3 of 2 times 8, and so that's log base 3 of 2 plus log base 3 of 8, and that's because you're multiplying inside the logarithm. 16 is 2 times 8, but then that's separate logarithms added together. So you take the numbers, those values, add them together. Now, you might notice that the answers are off by 1/10,000th. That's just a rounding issue. Nothing to get excited about, and certainly you'd want to show your work anyway, so everybody understands what's going on. Anyway, that is the end of page 1. Thank you for watching.